Hey guys, welcome to tutorial 3. Today we don't actually have too much to do, which is pretty good. Means that hopefully we're going to have some time to look over a few things that I wanted to go over from assignment 2, and in addition, some hints for assignment 3. So let's get started. All right. So with regards to what we actually have to do for today's tutorial, I'll post what Professor Moore actually told us we have to do, and we can run through it. So here it is. This is pretty hard to see, actually. We'll space it out. Cool. So we have 3 basic problems that we're going to use nested loops for. So all these problems have in common the fact that you need to use nested loops, aka 2D lists, which are basically a list of lists to solve them. So we can go one by one, and they're relatively easy. So you just make a cell below here, and let's try and do the first one. So using while loops, empty lists, and the append function, write a function that creates a 2D list, which is a list of lists, that corresponds to a times table. I.e., for each element of the 2D list, the value of that cell is the product of the cell's indices. Hi Basil, can we also go over some of the sample test questions? There is a sample test. I had no clue there's a sample test. Yeah, we can go and take a look at those as well. So let's do this one first. Using a while loop's empty list and the append function. So basically, let me show you guys what it's actually supposed to look like. So a 2D list is you're basically gonna have one list, which is your 2D list, and within that, we're gonna have a list of basically the times tables. So the first row, or the first list of this list, is gonna be the 0 times table. So it's gonna be like 0 times 1, 0 times 2, 0 times 3, blah, 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 blah. The next row is gonna be the 1 times table. So it's gonna be 1 times 0, 1 times 1, all the way forth, right? So you're gonna have 0, 1, 2, 3, 4, and so on. 2 times table. You guys get the point. So this is what we're trying to accomplish. That way, if we go ahead and do something like, if we call the function that returns this 2D list, we can use the indices to reference what we're talking about. So if we went like table 2 at 1, 2 would be talking about the inner list at spot 2, which is right here. And then 1 would be talking about the element at position 1 inside that list, which is right here. So 2, 1, 2 times 1 would be 2. That's what we're going for. Professor Moore says use while loops. I think in this case, using for loops is way better. It's easier to understand and it's more efficient. So we'll do that first, and then I'll also show you guys afterwards how you could have done it in while loops. It's very similar. Could you zoom in a little bit? Sure. Hopefully that's a bit better. Okay. So let's take a look. So first we want to make, actually I should probably keep that. We want to have our outer list. So let's make a function. We'll call it generate times tables. Generate times table. Cool. And first we want to have our outer list. So we can just say outer equals some list. And then we want to loop, and first we need to decide how big our times table is going to be. I think most times tables are like 12 by 12. So we can just go for that. So we can say for I in range 12, that'll actually go to 11 because it's 12 minus 1, but there will be 12 spots in it, so it's fine. We want to append an empty list because basically when we go through here, we want to append an empty list for like how many ever times we want, right? If we want 12 lists, we're gonna have 12. So we can just append an empty list here, just like that. And then here's where the nested for loop comes into play. For every inner list, we want to populate that list, right? We want to populate it with a times table values. So we could go for j in range 12 as well. We want to populate that specific list with the correct values. So we'd say outer at I dot append, and we could basically just say I times j, right? Because if I is 0 and j is 0, we're going to be talking about this element. We want it to be 0. So basically for this whole list, I is going to be 0. So I times j is always going to be 0. So we're always going to append 0. For this list, I is going to be 1, right? Because we're talking about our second inner list. And then all of these is going to be, j is going to loop through 0 to 11 inclusive. So it's going to be 1 times 0, 1 times 1, 1 times 2, all the way up to 11, right? That's basically what we're going to have. And that's basically it, right? If we do that, we make one list and then append one element for each of those inner lists, then we should have, that should be good. So we can test our function now. We can say print generate times tables. And there we go. That seems to be a times table, right? So here's your 0 times tables, your 1 times tables, your 2, your 3, your 4, all the way up to your 11 times tables. And the cool thing about this is we can now reference this, right? So this is just a list. So you know that if you know how with 2D lists you can reference them, right? Like if you had some list called my list, you could go like 2 at 3, and this would reference the second like the list at index 2 within my list, and then within that list it would reference the element at index 3. I'm sure you guys know about that. I think Professor Moore must have mentioned that. So we can reference our times table list in the same way because it's just a 2D list. So we can say, for example, 5, 7, right? We're printing the value that's at list index 5, and within that list, the value that's at index 7, right? Which is basically going to be 5 times 7, which is 35. And you'll see that even if we switch these around, it's the same thing, right? 5 times 7 equals 7 times 5. Go 11 times 11, 121. And that's the biggest value that we store. Because once again, this is our list. To visualize it nicely, if we just want to have one row, like one times table per row, we could just go for I in range 12, print generate times table at I, right? Oops, forgot the brackets here. There we go. So this function returns the list, and now we're just referencing the list. If you wanted to, you could do something like this. You could say times table equals generate times table, right? We're calling the function and we're storing the results, right? This returns a 2D list. We're storing the result here. And then we can reference that 2D list. So we can say print times table at 5, 4. And that would just be 20. Cool. So very simple problem to do using for loops. If you wanted to use while loops instead, it gets a little bit, I'd say just unnecessary in my opinion, since for loops do it so elegantly. But let's give it a shot. We're kind of going to have the same thing going on, but we're going to keep a counter instead, right? So as long as I is less than or equal to 12, and as long as j is less than or equal to 12, we're basically going to do the same thing. Here, every time we append within the inner lists, we want to add one to j, right? So we increment. So that we know when we're done incrementing to that list. So you can go j plus equals 1, And here, we can go I plus equals 1 to show us that we've done one of these, right? Like one of these outer lists. So every time I goes up by 1, we're done 1, and we're moving on to the next. Thing is, though, we can't forget to reset j. J has to go from 0 to 11 within this loop. And then the next time, when I increases and this starts again, j has to be back to 0. So we have to reset it. So we can assign j to 0 here. You can see what's going to happen. Ooh, shoot, yeah, we should definitely assign our variables first. List index out of range, because we went way past 12. We need to reset j. So j equals 0. And now it works. So you can see the basic differences between a while loop and a for loop. In this case, all we had to do was just add counters. We had I and j, we had to initialize them, we had to increment them, we had to reset them. It's a bit unnecessary for this question. I'll show you guys. Right, so zoom out for a second. Those are the two comparisons. Cool. So we can comment out this while loop for now. All right. And also, guys, for anyone who's in this tutorial section, which I'm assuming most of you guys are, I don't know if you saw, but on the Avenue page, there is a I added the content folder for our tutorial section, like I said I would last tutorial. So that basically, like, if you go to content on our Avenue page and you scroll down, you'll see right here there's T03, and that's got stuff from our tutorials. So for the first tutorial, I had our flowchart in our tutorial notebook, and then here we had the coding batch solutions that we went through last tutorial. All right. So that's the first thing. We've done our times table. We can move on to the second one. Let's take a look. Write a function that takes a 2D list and generates a formatted string where row elements are separated by the tab character and rows are separated by newline characters. Return the string from the function, and that's for me. Show how the students can print that separately from the function. Cool. So let's do that. So we can call this yeah, we're basically joining a whole 2D list. So let's call it joiner, and we're taking in we're taking in a 2D list. So we want a tab character. A tab character in between every row element. Row elements are separated by the tab characters, and then every row is going to be separated by a newline character. So I'm sure you guys know from the last assignment about the join function for Python strings. If you don't know about it, it's in Professor Moore's string function thing that's in content as well on Avenue. But basically what it does is you supply a character and you do character.join list. And that basically takes the whole list and it turns it into a string where every element of the list is separated by that string. So if we had a equals 1, 2, 3, or let's say hi, hello, bye, we can do print and we can basically join them. So we can go dash dash dot join a. This is a string. So it's this dot join is returning a string where every element in this list is separated by our separator character, which is what we call the join function on. Okay. So let's actually do what we're supposed to do and make it work. So it takes in some 2D list, and I guess we're gonna have to store it somewhere. So we can make a temporary list. And for every row in that input list, we want to add the string. Yeah, okay, so this is what we're going to do, guys. We're going to populate this list with the strings where every row element is separated by a tab, and then we're going to join that list. We're going to join this list, right, with a new line character. So every element in this list is going to be separated by a new line, and every element that's in this list is basically a string of every row element separated by a tab character. If it doesn't make too much sense, I'm sure once we print the output and you can visualize it, it'll make a lot more sense. So tabs in like tab characters in Python and in most programming languages are used are displayed using this backslash. That's basically how you show that it's a tab character. So we can use that as our separator, and we can say row, because this is for every row, right? And then we can say our final string is basically going to be new line character separating everything that's in temp. So here we're populating temp, and here we're joining temp, and then we should be able to just return a final string, sorry, not temp. So now let's try and call it. We can say print joiner. Hello. Hi, bye. Okay. All right. Cool. All right, so here we have a 2D list, right? I'll space it out so you guys can see it. So we have a 2D list here, right? And inside that 2D list, we have 3 lists. So if we run this, you'll see that every row element is separated by a tab character, and every row is separated by a new line. So that was done by joining every element in each row with a tab, putting them all inside an array, or a list, sorry, and then joining them together for the final results and returning that. That's how that works. And that matches the specification that we were given. So that works great. Next up, we have a 2D list and some value. And we're trying to determine whether or not that value is contained by the list. You're encouraged to use for loops and the in operator. So let's do that. So we can call this one table search because we're basically searching for a certain value in a table. It takes in a 2D list and it takes in a value that we're searching for, right? And this value is basically going to return true or false based on whether or not this value is found in this 2D list. Here's the thing though. Some of you guys might think, oh, you can just do something like this. You can return value in list2d. This would not work. And I'll tell you why this would not work. If you had a 2D list, cool, a 2D list like this, what the in keyword does in Python is it searches that list that you're talking about. So if I'm saying in list2d, it checks every element that's in list2d and sees if value is one of those elements. So what are the elements that are in list2d? It's this list, it's this list, and it's this list. It's 3 lists. Those are the 3 elements in list2d. And value isn't going to be any of these because value is going to be a number. So it says, is this list the number like 7, for example? If value is 7, no. Is this one 7? No. Is this one 7? No, because these are all lists and we're looking for a number. So we have to be a bit more clever than just return value in list 2D because that's not going to work. But I'm sure you guys can think of what is going to work. You're basically going to check each list that's inside the 2D list and see if the value's in there. So that's very simple. So we can just do for I in, I guess we can say for row in, for row in list 2D, we can say return, actually let me demonstrate something here. If value in row, return true. And then at the end, at the bottom here, we can just return false. And the idea behind this is that if the value actually is in this 2D list, then by the time this for loop is done, it will have returned true for sure. So we can just return false without any like if statement, because we know that it's only our program's only ever going to get to this line if it wasn't able to find the value in the list, in which case we do want to return false. So that's fine. I just wanted to demonstrate to you guys that saying like if value in row return true, you can basically just say return value in row, because value in row, this is going to return true or false, like this conditional, because this is a Boolean, right? Value in row, it's either in row or it's not, so it's going to return true or false. So you can just return that because you know. Actually, that's not true. That's not true. That's not true. That's not true. Sorry, this is wrong. Because we would return false right away. So let's actually fix that. The reason this is wrong is because as soon as value is not in the first list, it's just going to return false, which is not true because we want to look through the whole list. So we can basically hold a variable and loop through and check to see if we can find the value in each list, each sublist, right? So, do something like ans equals false if value in row ans equals true. Then we can just return ans. So this should work. And if you take this, like I guess we could just use this. Actually, here, let's copy this and then undo so we get our other 2D list back. There we go. So we can print table search on this. And table search takes in two values. It takes in this 2D list as well as a value. So let's say we're looking for 4. It'll return false, right? Because 4 is not in this 2D list. But if we say something like 6, 6 is in the 2D list. It's in the list at index 1 at element 1, right? If we were to print table search 1, 1, keep forgetting the brackets here. Oops, sorry. Just call this my list. Then we can just put my list here. We can say my list here. Right? My list at 1 at 1 is the list here, which is at index 1, and then the value at index 1, which is 6. So that's all the problems that we have to go over. Here it is as a for loop and as a while loop for the times table question. We had our joiner question where we formatted a string using the join string function. Then we also had a searching function that basically determined whether or not a value could be found in a 2D list. And I'm just going to bring this back to for I in range length of right here. There we go. Okay. So yeah, this is basically it. I'm going to save this. And yeah, this is going to be on Avenue. So I wanted to go over a quick question. So we're going to add another cell here. I wanted to go over something that a lot of people struggled with from assignment 2, which was subset sum. And I'm not sure if you guys remember that question, but it basically went something like this. It was the write a function that determines if there are any two numbers in the list that add to S. Do you guys remember that question? That was question 2 from assignment 2, part 2. Okay, so you basically had to go through a list and check to see if any two elements could add up to the target sum, and you had to make sure that you couldn't count it as true if you were trying to use the same two elements. So you couldn't use the same two elements to try and sum it up. That's why it says here, you cannot use the same value of 3 twice, which is why 1, 2, 3 would return 6. Cool? So I'm going to quickly code that up for you guys, just so you guys can see it. Because it's actually really not that bad of a question, but you have to really think about it, right? So let's have an example here, right? We have something like 1, 2, 3, 5, right? So this is our list, and this is our target. We want to go through every possible combination, right? Every pair of numbers, and see if they can sum up to 5. But we don't want to use the same number twice. So I'm sure this is the most logical approach is to use a nested for loop here. You want to use 2 for loops, because if you want every combination, first you want to talk about this one, right? And for this one, you want to compare it to every other element in the list. So you want to have 1 and 2, 1 and 3. And then for this 2, you want to have 2 and 1, 2 and 3. And for this 3, you want to have 3 and 1, 3 and 2, right? There's obviously a bit of overlap there because 1 and 3 is the same thing as 3 and 1, but we don't really care about efficiency. We're just trying to get the right answer, right? So you could just say for I in range, or let's actually make our function first. Define subset sum as ls, right? And we want to keep our indices here. Like, keep in mind that I could have gone for I in L, but I'm not. I'm going for I in range of length of L because I actually want this I to iterate from like 0 up to something. Like, if these numbers were like 6, 1, and 4, like, I don't want I to be 6, then 1, then 4. I want it to be 0, then 1, and 2, so I can so I can check to see whether or not I'm comparing the same two elements, because I don't want to do that. And the only way I can know how to do that is by using indices where I'm talking about the position. Because then I know that if I and j are the same, then I'm talking about the same two elements. And I'll demonstrate that real quick. But here you're basically just going to say, obviously, if L at I plus L at j equals S, return true. And we're going to have the same thing here, where we're returning false at the end, because we know that if it goes through the whole list in these nested for loops and doesn't return true, that means that it couldn't find any two values that summed up to our target sum, right? Now here's the thing though. This is going to go through, like this is going to go from 0 up to the length of L exclusive. This is going to go from 0 up to the length of L exclusive, right? Which means that you're going to have, for example, I is going to be 1 and j is going to be 1, right? Let's say you had 1, 2, 3, 6, right? When I is 2 and j is 2, L at I is 3, and L at j is also 3. So we would return true, because 3 plus 3 is 6. So we would say, oh, we found a combination, right, a pair that matches the sum, but we don't want to do that because we don't want to consider the same elements of the list twice. We're not allowed to do that. It says so, right? You can't count the same value twice. So when you're using indexing like this, right, it's so much easier to check that, because you could just say, if I is not equal to j, right? You just add that condition. You and it with the rest of the stuff. Like you say, yeah, obviously they have to sum up to S, but in addition, they also, I and j can't be the same value, or else we would be talking about the same elements, right? And that's it. That's really the whole question. So if I pull over the sample tests for that question, it's obviously all true. And if we were to make one more and test what I'm talking about, 1, 2, 3, 6, this should be false, right? Because you can't have the same value of 3 twice. And you'll see that we're right. It's true. Our function does actually return false for this function call. So that's subset sum for you guys. I hope that makes sense. It's really not that hard. Like you just have to loop through every element, consider every combination, and then just add that condition, right? Just make sure that you're not comparing the same two elements, right? Because if we remove this condition right here, then we're going to fail this last test case, because now our function is counting this 3 twice. Because I is equal to 2, j is equal to 2, so L at I plus L at j, these are the same numbers. You guys get the point. So we add this back in, and now we pass all the test cases. Cool. Okay, there is another question called arithmetic mean. Arithmetic mean, and I know this wasn't hard, but I just wanted to kind of show you guys what Python can really do. Python is a very flexible language, and there are a lot of functions. So arithmetic mean was question 1C from part 2 of assignment 2, and it basically asked you to find the mean of a list. So given a list, you had to find the mean of all the values in that list, right? So a lot of you guys did like sums, like you kept a sum, right? You did sum equals 0 for I and L. You did sum plus equals I, and then you returned. Let me just do my sum, because sum is a keyword, which is actually pretty relevant to what I'm about to say. Sum is a keyword. You did return my sum over length of L. And if you called this print mean on like 1, 2, 3, 4, 5, it would tell you that your mean is 3, which is true. This is like, you can totally do this. This is probably the better way. I just wanted to show you guys that Python has things built in that would make this a lot easier. There's actually oops, there's actually something called the sum keyword. So you can literally pass in a list to the sum function and it will calculate the sum. So you can just return the sum over the length, right? And that's basically the mean. So if we cancel this out and brought this test case over here, we would get the same thing. So like basically the point I'm trying to make is that Python has a ton of functions and you should definitely do some Googling. Like if you have a problem statement, just do some research and I guarantee you, you'll probably find things out that you didn't know before and it will make your problem solving a lot easier. Okay. Let's see. What else should we do? Okay. So I know you guys have this assignment right now. Oh, actually, yeah, this is pretty important too. I wanted to go over the bonus question, which is boring strings. Some people had some trouble over that. And boring strings was pretty simple too. You had to find if any sequence of 3 letters appeared more than once in the string. And you could assume only uppercase characters and spaces and stuff like that. So really all you had to do is calculate every 3-character subsequence, and you could use the count keyword for Python, the count function, to check to see how many times that substring occurred in the string. And if it occurred more than once, then you could just return true because the string was boring. So we can code that up really quick. We can say boring takes an S. Oh, for this, it would work fine. Some is like all the Python keywords usually are pretty. Never mind. Actually, length of L. Sorry. So some would work here, but length wouldn't. So you're actually right. Thing is though, does the mean function, did it actually ask you to account for an empty list? I think you could assume that there wouldn't be an empty list, but that's a really good observation, Marvin. Yeah, it would crash because length of L is 0, right? But if you do where is it? Here we go. If you were to print length of the empty list, it wouldn't crash. It would just tell you 0. But yeah, good spot. Good spot. This is absolutely fine though because I'm pretty sure you can assume that you're not going to have an empty list. So here for boring, we can say for I in range, and we want to be careful here because we're let's just leave this blank for now. Our substring is going to be equal to a slice, right? We're going to use Python slicing to get sublists. We're going to go I all the way to I plus 3. And remember that this is exclusive by 1. So it goes up to, but not including I plus 3. So it'll actually go to up to and including I plus 2, which is good because we want a substring of size 3. So it'll be the character at I, the character at I plus 1, and the character at I plus 2, which is a substring of length 3, right? And then using this, we know that once we get up to the, once I becomes the index of whatever our length is, minus 3, that's the last thing that we can go at. Because the last element in the list is the index, length of list minus 1. But range is exclusive as well. So we're actually going to have the length of S minus 2. And like, if you can't really see like why based on the explanation, like it would be really clear if you just kind of drew it out. But for the sake of time, like I just won't explain that because basically like if you had something less, like length of S minus 1, you would go out of bounds because I would go up to length of S minus 2, and then you'd be adding 2. So you'd be length of s. And there is no elements at the index length of s, right? If you have a... Anyways, I think you guys understand that. We can now just check. We can basically just check if that substring, right? If that substring occurs in S more than once. Like we know it occurs once because we're checking it right now. Like we've calculated it. But we want to see if it occurs more than once. And this will work. This will totally work. If you pull some of these sample test cases right here, you pass them both, right? So I think those were some of the two complicated ones that people found from assignment 2. Question 5 about the checksum was also really confusing, to be honest, in its wording. Can you explain your substring again, please? Yeah, for sure. So let me do an example. Right? So let me go a lot simpler. I at I plus 3. So we're starting at I, right? We're starting at index I, and we're ending exclusively at I plus 3. So I's range 0 to length of s minus 1. So what's length of s? Length of s is 5. So we're basically saying range 0 to 4, right? Because length of s minus 1 is 4. Sorry, like 5, but I is going to go from 1 to 4 exclusive, right? So I is going to be here. I is going to start off at 0. So s at 0 is going to be here. I plus 3 is going to be 1, 2, 3. So it's going to be at C, but I plus 3 is exclusive. If you Google substring for Python, you'll find that the second argument is exclusive. So we don't actually include it. It's up to but not including. So we're actually going to land on the I. So you'll have this substring, ALI, right? You'll check if the count of that substring is greater than 1 in S. So we'll say, does the string ALI occur more than once in our string S? The answer is no, it just occurs once. So we don't return true, right? And then I increases by 1 because this is a for loop. It increases by 1. So now we consider this section. Cool? And the same thing. And the reason why this is length of s minus 2 is because, okay, cool, you understand, perfect. That's basically it. Let's take a look at someone said the sample test. I didn't even know there was a sample test, to be honest. Is this it? Practice test, master? Okay. Cool. Yeah, I've never seen this before. Oh, look at that! Write a function num increasing. That's your first problem in assignment 3. So once again, guys, assignment 3 is great practice. Write a function num increasing that takes as input a tuple of numbers and returns the first sequence within the tuple that is increasing order and has length at least 2. Does the test cover up to assignment 2 or 3? You have to assume that it covers everything you've learned so far. When does assignment 3 due? Yeah, I would consider that it covers everything in terms of content, but yeah, it shouldn't be insanely hard. Right, Sunday. It's always due Sunday. I don't know why I asked that. 24th, and the test is on the 23rd. Okay, so man, that's a tight deadline. You guys are gonna have the test and the assignment really close together. Okay. Yeah, since it's really close to the deadline for assignment 3, I would assume that the test can include content from assignment 3. I would definitely prepare for it. And you know, like if it ends up being not too much assignment 3 content, then you could just take that as a blessing, I guess. But yeah, things do start ramping up. Yeah, the issue with extensions is that like yeah, I get it, Matthew. Like with extensions, since the assignments are like every week, as soon as you extend, like if people start working on assignment 2 too long into the next assignment, they will have like no room for assignment 4. Yeah, and like since the summer course is so compact, it's really hard to fit stuff. And like move stuff around. Like we really don't have too many days to work with. So write a function num increasing that takes as input a tuple of numbers and returns the first sequence within the tuple that is increasing order and has length of at least 2. You can assume blah 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 blah. Okay, cool. It's actually this is basically the same thing as your assignment. So wait, are there? Oh, it's just a PDF. Okay. Okay. Outside of coding bat, what would you recommend for something that'll give a bit more challenging questions? Honestly, your assignments. Like, I think the assignment questions are challenging enough. If you're able to do the assignment questions, you should be fine for the test. If you're able to do the practice test, you should definitely be fine for the test. And keep in mind, like some assignment questions are obviously harder than others. You don't need to expect to be able to get all of them perfectly. If you can, also a tip for the test, guys, and all exams that are based on like auto-graded Jupyter Hub type stuff. If you find that you're not really able to fully solve a problem, always try and go for some part marks. So try and return anything that will at least match some of the test cases, right? If you can match some of the test cases, then you really will be fine, and at least get some part marks. So let's go for this. Length of at least 2. I mean, since this is a practice test problem, I think I can show you guys how to do it, or at least go over it. So we take in t, right? And wait, does it have the same restrictions? Oh, you can assume such an increasing sequence always exists. So that's a bit different than your assignment, because you couldn't assume that an increasing sequence always exists. If it didn't, you had to return a list of just the first element. But this one is a bit different, which is good. So let's go for it, I guess. So we'll have answer. This is where we're going to store our answer, like our increasing sequence, our first increasing sequence. And let's think about this. Okay, for I in range, and then since we want to compare I and I plus 1, we actually want to go length of t minus 1 because we don't want to overflow, right? If I is our last character, like our last element, and we try and go one past, we'll go past the list. So we want to add this. And then we're basically asking ourselves, is L at I less than L at I plus 1? And if it is, then we have an increasing sequence, right? In which case we depend L at I. And then, yeah, so else, right? Which means that if these aren't increasing, if our sequence isn't increasing, and our length isn't 0, if our length of our answer isn't 0, we want to instantly return, or not return, but I guess break. Actually, let's try returning. Are there test cases at all for this? There are no test cases. We'll have to make our own real quick. Return answer. Actually, let's change this a bit. Let's do else. Maybe first append L at I, because if in this else statement, right, this assumes that we don't have an increasing sequence anymore, because L at I will have to be not less than L at I plus 1. We still want to add L at I. We don't want to add L at I plus 1, but we still want to add L at I because that was still part of the increasing sequence, I think. We'll see. And then otherwise we could just return ants. Think. So let's make some test cases, I guess. There are these test cases I have from all right, we have an error. Oh yeah, so these are calling, and also these are taking lists, and we were supposed to be giving tuples. Oh boy. Wait a second. Yeah, okay, this makes sense. What does it say about a return? What should we be returning? Are we returning a tuple or? Okay, I think we're returning a tuple based on, like, it says the first sub sequence of the tuple, I'm guessing. So we can say tuple. Yes. And we'll say tuple. And it's here. Then we also got to convert these to tuples. Oops, we were using L here. Should have been using T. I'm too used to doing. Okay, we are failing some stuff. Let's see why we're failing some stuff. And this one. Okay. So we're not tacking on the extra one at the end. Right. Okay. So we're clearly just forgetting to append again. So let's say ans.append. Ans.append, we want to append the last character. So it'd be t at -1. So now we're getting 1, 3, 4, 1, 4, 5, 6, right? I think that's good. So if we comment these back out, there you go, guys. So I hope some of this makes sense. Yeah, I'll upload this to the Avenue again. And keep in mind though that this is a bit different. So you can't exactly use this like copy and paste for your assignment because it's missing the condition. This condition is different. You can't assume that an increasing sequence will always exist in our assignment question. There might not be an increasing sequence, and if so, you have to return a list of just the first element. Cool. Yeah. If anybody has any questions about this solution or anything else we've done this tutorial, feel free to ask. Or anything else, because we're basically done tutorial time, but I will once again stick around if anyone has any questions. Ah, thank you. I appreciate that, Darth. Thanks. So is t at -1 guaranteed to be in the increasing order? Oh, that's a good question. That's a very good question. That's a very good question. Let's do something like this. Let's say, oh, you're right. Good call. Good call. Let's do something like 1 here again, right? Well, our thing still works. Like even if I add a 1 here, so what? Okay, what's happening here? So we're going 1, 3, 4, right? We get 4 here, and then this ends up being I, and this is I plus 1, right? This is t at I, this is t at I plus 1, and t at I is not less than t at I plus 1. Ah, there you go. There you go. Here. So this is what saves us, Ignacio. Basically, right? Imagine I, like our looping variable, trucking along, right? And then 4 will be t at I, and 1 will be t at I plus 1. since this condition isn't true anymore and our increasing sequence is over, we'll check this. And since the length of answer isn't 0, because the length of answer is 3, right? It's 1, 3, 4, we will execute this code. We'll append t at I, which is 4, or sorry, I guess it was 2 earlier. It'll append 4 and it'll return that. So that's our saving grace. So this code will only ever activate, it'll only ever run if you go right till the end and the increasing sequence goes right till the edge. Like just like in these examples where it's like 4, 5, 6, right till the end it's increasing, right? That's why we need this. Could you do ants equals ants dot append t at I and then the final part return ants so you don't have to do tuple? I'm not sure if I understand that. I'm not really sure what you mean. We need to we need to return a tuple because that's just how I interpreted this problem. It says returns the first sequence within the tuple. So I'm assuming that it has to be a tuple. So I used lists so I could append to them, and then I turned it into a tuple at the end because I obviously can't return the list that I was using. Yeah, no worries. And no problem, Tay. I'm really happy that you appreciate it. I'm trying my best, but I know this course can be really hard at times. So I appreciate you guys trying your best and, you know, coming for help when you need it. It's good stuff. Any other questions? Yes, sir, Matthew. That's really all it would take. But I'll leave it to you to decide on where to put that if statement and or like that else statement and what to put in it. I'm sure you can figure that out. That shouldn't be a problem. That's a very simple modification. But this really is the bulk of the problem. And it might not be an else statement. It might be an if statement somewhere else. Like there's a bunch of different ways you could do it. Just keep playing around with it until you find something that works. And yeah, for sure, just go with your gut instinct first and see if that works. We don't need to handle the exception in the test. What do you mean by exception? Do you mean like invalid input? Because you definitely don't need to handle invalid input. You can assume that the input's going to be what they tell you it's going to be. Yeah, you can assume that if they tell you the input's going to be of a certain form, that it will be in that form, unless they tell you otherwise. But yeah. All right, any other questions, guys? All right, cool. Thank you guys all for coming. Thanks, Matt. I'll give it my best shot. And I hope you guys give it your best shot too on your test. Take it easy, practice the practice tests, do all the assignments, and if you guys need any help, come to Piazza, all right? I'll see you guys. Good luck.